All right. Welcome to our third lesson, Introduction to Programming Concepts. So today you're going to learn how computers think through code. All right. So now, why do programming matter? Every software product is powered by programming. I mean, everything's about coding. You program the banking transactions, login systems, the e-commerce. So without programming, softwares don't function. So the question now becomes, what is programming? You know, it's about writing instructions for the computers to follow. Think of it like AI and prompts. When you give prompts to AI, you're giving instructions. So with programming, before the discovery of AI, what they do was to use codes or specific syntax languages to communicate with the computer, to follow some instructions. Computers do not guess, they execute commands, right? So there's no guesswork, not like the way we have with AI. That's the advantage we have with AI. AI is a bit more accommodating, right? So it can interpret your guess, try to analyze it, and identify an instruction from it, or follow a recommendation, or give you a feedback suggestion. All right. For instance, if you click on login, it goes to verify credentials. It's not going to guess whether this person is part of us or not part of us. It has to follow the instructions. All right. Another thing you should know about programming is problem solving. So it's identifying a problem and being able to solve it. So every developer starts with problems, not code. You don't just start coding, you're solving a problem. There's an agenda, an objective to be met, right? For example, so if you're doing checkout abandonment, it goes to a simplified flow. Do you understand? All right. So the major thing, like, okay, oh, some people are having problem in e-commerce, right? And let's say after they finish they're picking up their products, how do they check out? All right, then we write a code about that. Someone thought about it. Have you ever been to some offices, especially real estate offices, and then you see there's an app there that onboards you for visiting? Someone thought about that kind of problem, and then they began to code. So every programming starts from problems, not code. Programming translates solutions into systems. Now, this is how computers think. They think about input, then they process that input, and then they deliver the output. For example, if you put in password, it checks whether that password is logged in their data in the database, and then it either grants access or it gives you a denial. And that takes us to logic. All right. So humans assume while computers require precision. So if there's no instruction, there will be no action. And if there's confusion in your instruction, I can assure you that there will be no positive output. All right. So one of the core building blocks we need to understand when it comes to programming is things like variables, data types, operators, conditions, loops, functions, arrays, and objects. Now, we would have gone into all these things in detail, but when we are building apps with AI, we don't need to bother with all of this. The AI does all of that. All right. So variables will refer to different inputs that will be required by the computer, all right, for different functions. Okay, now they have to be defined, all right, for the computer to be able to analyze them. So they're like inputs from the user that the computer will have to define to be able to use them. All right. So there are data types that means, and it basically because of reference sake. So it has to categorize those data types. All right. There are operators that will service those data types. There are conditions which I'm talking about. That's logic area that has also handles iterations like loops, and then functions and arrays and objects. Now, all of this, you don't bother with head with it because you're going to see the AI, helping you out on all of that. All right. So when you talk about variables, you see containers for storing data. So things like username. I told you these are inputs that the user will have to provide, right? Username, age, is logged in, and all of that. So what that does is that it takes in those inputs, categorizes them, defines them, right? And then references them for other functions. Now, why variables matter? It enables memory, calculations, and tracking. It's very, very core to every application. So also have data types, um, like it's like the data that is being put in has to be stored in a particular way. So we have string, we have boolean, we have numbers. Have you ever seen when you're trying to put in a number in a form application and it doesn't allow you to put any other number? You can't put a letter there. It has to be numbers in a particular format. That's a data type. That's like it's been strictly put in to have that format to be able to um, only accept a data type that is numbers, right? So string we have to do both numbers and letters, but not basically like the way you know it, like words, right? So there are things like array, so there are certain things like JSON and the rest. Okay, so that's data types. All right, let's just use an example to explain this better. So let's say an e-commerce data example. All right, so you see things like product name. Of course, that's to be string. All right, so that means that is string is a bit more encompassing, takes in both your normal alphabetical characters and then also your numbers. Um, then you see price. Price is in numbers. Then if it is in stock, so in stock we check true or false. Boolean has to do with true or false. So in stock it checks whether it's true or false. Boolean. So that's be the data type. So you put in cart, things that are that like what when you order cart and you put it's in array, that the data type in that scenario will be array. And then of course the customer will be the object. So when you talk about operators, they are basically things that are necessary for computation in the functions. Things like the plus, the minus, the multiplication, the divide, icons. All of these things are operators that have different meaning. They don't mean what I just said now in the coding. They don't mean that. Okay. So let's say for an example, a pricing example, let's say a price of 10,000 naira and there's a discount of 2,000 naira. Of course, the final is 8,000 naira. All of this is computed from all of that. All right. So to explain this a bit better, so it checks in, oh, this is the price, and then it establish one of the operators of subtraction, and then gives you the output. I'm just giving a simple flow so you can just understand this. All right. So when you talk about conditions, what that does is that it enables decision making. So you basically use logic gates like if, else, and, or, and all of that. We will see that in practice. This is just basically theory giving you a foundation to it, but when we get into the practical, you will understand it a bit better. Now, why do conditions matter? It helps with things like login. So when you put in the name, it's just if this value is true. Now you see, is true is already boolean. In the database, it gives access. If else, it gives a rejection. Things like that. Payment, where you do not check whether the value of the or what is paid is equal or less than the one that is at the balance. So if it's equal or less than the balance, then it of course the payment cannot go through and all of that. So it's all of these conditions matter in the depending on the function that you're trying to uh, you know implement. So an example is login example, which is what I just told you. If email exists and password correct. So that way you see sometimes when you put a wrong email or a wrong password, you tell you invalid email slash password. So to let you know that it doesn't tell you which one is exactly whether it's the email or the password. All right. So loops, so these are like actions that are repeated automatically. So this can be coded and you can actually stretch a number of loops. In actual coding, it can be you can actually set up a protocol for loop without having to have a loop of functions. I don't know if you understand. It can be a very simple command that will set up a protocol of loops, and that also is one of the ways that viruses are created. Viruses are created in such a way that they can bring in an infinite set of loops to in order to maybe damage the system and all of that. Okay, very very useful for bulk operations. Now, where use loops are used, things like notifications, product listing, payroll, comment, and reports. All right, so let's go to functions. We've dealt with variables, we've dealt with data types, we've dealt with loops. So let's go to functions. So functions will refer to reusable blocks of logic. So logic that can be repeated in different format, but that systemic. So basically, it's a systemic application of logic. That's the best way I will describe it. All right. For example, calculate total. All right. Calculate total. That means it just calculates everything. So you can, if you go to Excel, for those of you that have used Excel, so you can, you can program that all the columns in a particular thing can be summed up into a cell block, right? And it works well. So why functions matter? Gives you cleaner code, reusability, faster development, easier debugging. All right, so let's go to arrays. I'm just defining and giving you a brief introduction to these things. All right, arrays store multiple items. You can also like example that you can use cards, reports, just multiple items that are arrayed in a particular layout. All right, so again, we have objects, so that means group related data. Example, things like customer profile, of course, it will also include profile pictures and all of those things. Let's still we put everything together. So you see cat array will go to total function, condition check, operators deduction, and all of that, and then return success message. So this is just like a flow, all right? So from a cat, all right, this is a function that treats that cart to check out. All right, it checks, and then when it is a condition check, like for instance, you put in a product that you wanted to buy, and then it checks that the amount for that product is equal to the total balance you've got. Then it deducts the money, and then gives you a success message. Something simple. Now here are some beginner mistakes we do in programming: memorizing syntax only, fear of errors, and then some people get too discouraged that it's too bulky, it's too tight, it's too stressful, they give up too early. Here's best way to learn: understand concept, practice daily, build small projects, start small, and then you can build up from there. And that's where AI comes in. AI explain, debug, generate code, and do the whole logic thinking for you. All right, but you must still be able to envision it. Even though I say AI does the logic for you, I'm referring to the logic in the coding, but not necessarily the logic in how the algorithm is supposed to be like. You also have to be able to envision the algorithm. AI would not, like I'll always say this: intelligence with AI is not absent of your intelligence. It's just that AI boosts your intelligence. I hope you understand. All right. So another practices exercise that we can think of is ATM logic. If balance is sufficient, approve. Else, insufficient funds. So you see this kind of simple functions that explains a lot. All right. So you can do a mini project on student grading system, score that just A, B, C or fail. So it checks if your score it meets the pass mark. If else, either gives you fail. If not, if it's above, it gives you a pass. All right. So one of the key takeaways you take from this to this class: program is equals to logic plus structure, problem solving, not just code. So don't think about code, think about problems, and then when you're able to solve those problems, then you can apply codes to solve it. All right. So our next module will be discussing programming languages and environment. And then we get to start writing real code.